Professor Jane Greaves in the UK actually decided to do something very bold, and she decided to look for signs of life on Venus by way of a gas that doesn't belong. And she looked through the literature and read about this gas called phosphine. And on Earth, phosphine is only associated with life. It boils down to the fact that you have a phosphorus atom and 3 hydrogen atoms. And there's not a lot of hydrogen here on Earth. So phosphorus wants to go with oxygen. It doesn't want to go with hydrogen. Somehow life seems to do it though. So she went to study that, and my team, we had been working on phosphine for exoplanets as a potential biosignature gas. And so a mutual contact got our 2 teams together, and ever since then I've been working on Venus. Professor Greaves found a signal of phosphine, and my team helped show that we can't explain it by chemistry. That there's no chemistry we can think of, whether it's meteorites or lightning or volcanoes or anything really. We can't explain it. And so there's either unknown chemistry on Venus, or perhaps, sort of very off chance, there could be life in the clouds making phosphine, because Venus is way too hot for life at the surface. But up in the clouds, Venus is actually just the right temperature for life. So it's kind of a long, complicated story, but a lot of other teams have now looked at the data. Some of the teams do not see phosphine in the data. Other teams do see it. Some teams claim that it's not phosphine, that the signal is another molecule called sulfur dioxide. Some teams claim there's sulfur dioxide in the clouds. Other teams say it can't be in the clouds, it has to be way above the clouds. So the whole thing is kind of a giant mess right now. And we're just sort of, we stand by our original claim that there is phosphine, but we'll see what happens. So about Venus and whether there's life there, we don't know. But people do think that Venus had water oceans in the past. And the idea is that there could have been life in these water oceans. And that as the planet got hotter and hotter, life migrated to the clouds and found a way to permanently stay there. Because our own planet Earth, by the way, we have life in the clouds, like microbes, and they're not there for very long. They get swept up from the surface by winds. And they might get inside a droplet and stay there for about a week or so, and then they drop back down. So it's very different than Venus, right? But because it doesn't have to stay there. Looking at Venus, surprisingly, is actually quite hard. It's so bright, way brighter than our telescopes, our big telescopes were designed for. And it's also spatially resolved, like it's really a disk, not just like a point like a star. So it kind of confuses the telescope. And a lot of this data is very noisy. Like instead of being just, like think about the stock market, it's like up, down, up, down, up, down. And there's a lot of wiggles in the data. And I can actually explain it quite simply to you, actually, that traditionally in radio astronomy, because this is done with radio astronomy, you have the wavelength or the frequency where your spectral feature should be. And then you just take away all the wiggles, you detrend the data away from that spot. And if any signal remains, then voila, you have found it, because it's exactly where you thought it would be. What that means though is that the drop in signal where your feature should be, it has to be kind of characteristically different from the noise. So say the stock market goes up, down, but there's a very specific feature somewhere. This feature just has to be different from the general kind of up, down, up, down. The teams that don't see it, typically, they're just detrending the data. They're taking away every wiggle, and they also remove the actual signal. But it's really people fighting over what's the best way to do data analysis for data that's very noisy, because we were looking for a tiny signal, so tiny. And I'm guessing there's other fields like this as well, where you really have to, sorry, it's bad, but you have to really, really dig. Hopefully it's just a matter of time. I mean, the best thing to do would be to go to Venus and send a probe there, and to look directly, go in the atmosphere and drop a probe down. And we have sent missions to Venus that dropped probes down in the 1970s and 80s, but that was a very long time ago. So they didn't look for phosphine, but oddly enough, a team went back and revisited some of the data. Well, when they reconstruct this analysis and look at it, they think they see signs for phosphine.